Okay, we are going to review for our exam. This is the first unit practice test. You were given the answers, but we're going to take a look. I'm going to get you to star specific questions. This is the first question you're going to star because you're going to see the diagram. It's very similar. So almost identical, but I asked a different question about the diagram. So let's just first of all identify what's going on about the diagram here. So what do we know about the standard deviations of A and C, just generally? They're the same because they have the same height of their peak, okay? So that means this guy right here and this guy right here have the same standard deviation, okay? Now, what do you know about the standard deviation of B? It's bigger than the other two because it's more spread out, okay? So if you see a lower one that's more spread out, that one's going to have a higher standard deviation, okay? So the mean, let's look at the mean. The mean is where it cuts down the middle. So the mean of C and B is identical, it's 50. And the mean of A is 10. Now let's look and see what it's talking about here. The mean of C is identical to the mean of B. Is that true? Yes. So A is true. B is bigger than the mean of A. Is this mean 50 bigger than 10? Yes, so that's true. Standard deviation of A, so that's how spread out everything is less than the standard deviation of B. So that means the spread of A is closer, it's less than the spread of B. True or false? True. Okay, standard deviation of A over here is bigger than C. Their spread is bigger. Well, let's take a look at the spread. Spread here shows 20. Over here, what does the spread show for C? 20. So is this true? No. So D is the not true. D is false. Okay? So it's easier to identify what we know about the diagram and then read the statements. Does that make sense? Okay. All right, let's move on to numeric 1. Numeric 1 tells us that we've got Tom, he's 185 centimeters tall. Now, that corresponds to a Z-score of 143. So that's what they're telling us about the number 185. It says the heights of the students are normally distributed with a standard deviation, so they're spread out by 3.5. It says the average height. So we want to find the mean. So in order to find the mean for this question, we need to use the mean equation. So we're going to be using mean equals x minus z times standard deviation. Okay, now the reason I'm using that one is because it's asking for the average height. Now, would I be using that one or would I be using n times p for mean? How do I know which one I'm using? Depending on the information they give you. So did they give me an n number and a probability number? No, they didn't give me a total of anything. They didn't tell me how many kids were in the class, and they didn't tell me the probability of anything. They told me a Z number, a standard deviation, and his X number. So, since I know an X number, a standard deviation, and a Z number, I have 3 out of the 4 numbers I need to solve. That's why I'm using this one. Okay? So, we're going to plug the numbers in where they go. So, X is 185, minus 8. Z-score, 1.43, timesing by 3.5. Now, it's in brackets on purpose because you must multiply doing bed math before you subtract. So we're going to multiply those first. And how big do we get when we multiply those? 5.005. There we go. So now we're going to get 185 minus that. So that's going to give us 179.99 something. 179.995. So it wants the nearest whole number. What would that round to? 180. So the nearest whole number, it's going to be 180. So the mean for that one is 180. Now, how could we check our work on that question? How could you check your work? Well, let's take a look at the first statement. 185 is a Z-score of 143. Can we check and make sure that's true? Yeah, we can. We can go into our Z-score equation now x minus mean divided by standard deviation, we can put all the numbers in there. I can go 180 minus, or sorry, 185, because he's 185 tall, minus the mean of 180, divided by 3.5, and when I do that, I should get his z-score answer. Okay, so that's how you can check your work. Okay? Good to go? All right. The next one, the minute you see a list of data, what should you do? Put it in the calculator. So you're going to go stat enter, and you're going to put that in the calculator. Once you do that, you're going to get your mean and standard deviation. Which number are we looking for? Standard deviation. You want this number. Okay? So when you do the data, which one should it be?
26.7.
Right, 26.7. Okay, I'm going to take a look at the next one down here. So, because this question here, if you read the information, deals with this information. Now it says the average number of CDs. Which one does it want? The mean. Good. This one wants the mean of that question. So whenever you're doing a list of data, chances are you're going to need to find a lot of information out about it. So what you do is you list the information and then you solve the questions. So this one wants mean, so we get 37.6 is what it should be. Okay? Pardon me? No, because it wants to the nearest 10. Yeah. All right, so watch your rounding, you guys. It's going to be 25 marks. There's 5 numeric response and 20 multiple choice. Okay? No written on this one.
Okay.
Oh, I could give you a really easy one.
Let's do.
Can you shade the right area and do the Z-scores?
If you, for your N number,
Yeah.
how do you know if they're giving you an N number?
Okay. This next question has it. Okay, we're talking about the next question. This next question says the probability that a day in February will be sunny is 0.72. So it tells me straight up that it gave me a probability number. Okay, it tells me straight up. It labeled it probability. February has 28 days. What kind of number is that? It's a total. A total amount number is an N number. So now we've got N and P. So now we use this equation, N times P. So 0.72 times 28. And that's going to give us 20.16. So now we can cross off choices A and B. We know we're down to choice C and D. So now we go into this equation, N times P, 1 minus P. I would strongly suggest that you take the 1 minus P and do this subtracting before you put it under the radical sign. You already figured out the mean. Well, N times P right here is just the mean. So all it is the mean times the probability minus 1. So you're going to go 1 minus 0.72, and that's the number you times by the mean under the root sign. Okay? So 1 minus 0.72 is going to give us how big? Thank you. 0.28. So mean times 0.28. So what's our mean, guys? 20.16. So in your calculator, under the square root sign, you're going to go 20.16 times 0.28. All under the root sign. And then square root it. What are you going to get? Right, you're going to get 2.38. This is still for number 3. I'm just using a lot of space to write.
If you solve everything under the root sign and then just put that one answer under the root sign.
Oh, that's fine. Of course it'll work. You betcha. As long as you use every decimal. Okay, so yes, the answer is C. Okay, number 4, we got Sasquatch. Sasquatch tracks have been found through the Kootenays and have a mean length of 42. It says a standard deviation of 2.6. So we got to label everything, mean, standard deviation. The new tracks have a length of this. What data is that?
X.
The X. It's the raw data value. So we want Z-score. So we're going right to our Z-score formula. So Z equals X, 39, minus the mean, 42, divided by 2.6. That's going to give us a negative Z-score, A. Okay. Now I want you to star this diagram. You're going to see one very similar to that. But the descriptions are going to be a little different. Okay, I'll just move it up for you so you can see here. So the descriptions match down below here. Here, this one's just saying less than 16. So this one's saying less than, this one's saying more than, and this one's saying between. This guy here says less than this much, but more than this much. So this is the sections that should be shaded, okay? So when you're matching them, you want to find areas. Here you're taking a number that's shaded to the left. So which diagram shows something shaded to the left only? Number 2 only. Here it's shaded from there over. So the first one would be a 2. All right, which one shows shaded all the way to the right? Number 1. Good. Which one shows something shaded in between? 4 does. And then the last one, number 3, shows something shaded less than here and more than here. Okay, so that's how you would read those. Now, let's say I totally change this and I talk about maybe the temperature of boiling water, okay, or something like that. You're boiling water on the stove. Maybe I want to say which diagram is showing that it is greater than 60 degrees if water boils at 100. Well, greater than 60 degrees. If water boils at 100 right in the middle here, greater than 60 degrees. 60 would be on the left. Okay, what if I said it boils between these 2 numbers? It's obviously the one that's showing between, right? So you pick the guy that's showing between 2 numbers, which would be this guy. Where is it? Right here. Showing an edge here and an edge here, and shaded between. Okay? So you got to be careful with what they're talking about. All right. Let's take a look at a few more. What's the first thing you would have to do in this next one? This one is a bit tricky. Yes, because this one requires you to use all of your knowledge. So first of all, how many cards are in a deck of cards? 52 without the jokers. We always without the jokers. So how many hearts are in the deck? 13. There's 13 of each suit. So 13 and 52, that means their probability of pulling a heart is 0.25. So this is probability of picking a heart. Yes?
So if we want to test, and we didn't know how many cards were in a deck.
Exactly. Now what they do is they would give you a description and tell you. They have to.
Okay.
Yeah. Just this question didn't, but it would have to.
Okay.
Yeah. Okay, so 13 out of 52 are hearts. Okay? Now, you need to pick 6 cards. This guy picked 3 hearts. So 3 is going to be its X number. We got to find the Z score. Well, I need to know my mean first. Well, my mean is going to be N times P. What's my N number? How many cards do I need in my hand? 6. So my N number is a 6. So it's going to be 6 times 0.25. Okay, that's my mean. So how big is your mean? 1.5. So, now you know the mean and you have the probability. So, we want to find Z score. So, Z equals X minus mean divided by standard deviation. We need to find standard deviation now. So, standard deviation, I'm just going to erase the mean here just so that I can use some space on the board here. So we found our mean was 1.5. So now in the standard deviation equation, the first N times P is just the mean, times 1 minus P. Okay? So we've got the mean, which is 1.5, and what's 1 minus 0.25? 0.75. Good. So under the root sign, you are going to multiply 1.5 and 0.75. Okay, that's where these numbers are coming from. So 1 minus P and your mean. Okay? So how big is our standard deviation? And standard deviation, remember, is always 2 decimal points.
1.4.
The standard deviation is
Oh.
1.06. So now we've got the standard deviation number, we've got the mean number, and we've got the x number. We need 3 out of 4 numbers to show in that z-score formula. So, I know my x number. My x number was 3. My mean, 1.5. Standard deviation, we just found, was 1.06. Now I'm going to do all my math. Now you're going to find the correct z-score. If you wanted to put beside this question, SE, this is considered a standard of excellence question because of all the work it requires. Okay, because it required 5 different steps. So, which one should you get? Yes, C, 1.42. Okay. All right, let's take a look at number 6. First, you need to label everything in your diagram, or sorry, in the words. So let's label everything with our words on number 6. So, number of oranges in a crate with a mean. Here's my mean. Standard deviation. Percent that are expected to contain less than this much. They're giving us a raw score data. That's X. So whenever I need to find a percent or an area or a probability, I need to use normal CDF. But in order to use normal CDF to find that decimal, I need to know the z-score. Remember, we're trying to find out between -5 and +5 where it lies on that diagram. So, back to the z-score formula. 21 minus 23.4 divided by 1.3. That's going to give us Z. Okay? That's going to give us a z-score of -1.85. Now we have to look, since we only were asked to find one z-score, in the normal CDF we need to have 2 numbers. So we need to know, did it want us to use the +5 number, or does it want us to use the -5 number? Which word is going to tell me that? There's only one word that tells me that. Less. Good. So this word right here tells me which boundary I'm using. Less means I'm going to use the boundary of -5. So now I'm going to go normal CDF, which is second bar is number 2. -5 is my lower. My upper is -1.85. Enter. That's going to give you your decimal. You got to times it by 100 to get the percentage, which is going to give you A. Because you should get 0.03216, yada yada. Okay?
What if you have the upper and lower?
If you have upper and lower, lower, upper. Lower is always the bigger negative number. Okay, number 7. Number 7. I want you to star this statement list. That statement list you will be given again tomorrow on your test. Now, we want to know which of those are true versus which of those are false. The question tomorrow, you don't know. Is it going to ask you true or is it going to ask you false? We don't know. So we got to figure out which ones are true and which ones are false. So, just going to erase all this. Okay. So, the area under my curve is equal to 1.0. Is that correct? Yes, it's between 0 and 1, so it equals 1. Yes, that is true. Now, the curve, what does it mean by symmetrical about the mean? What does that actually say? Symmetrical about the mean. It's identical on both sides. So that means if you split it in half, you could flip it on top of itself and it looks like one diagram covering the other. Okay? Mirror image. So, that's correct. Almost all the data lies within 2 standard deviations. So from -2 to +2, they're saying 99.9% lies in there. Between -2 and +2. No. How much lies between -2 and +2? 95. So this guy's wrong. Almost all the data lies within 3 is what we're showing. Okay, almost all the data lies within 3, not within 2. The area under the curve is also known as probability. True? The value of one standard deviation below the mean, to the left of the mean, has a data value of a positive 1. No. If it's below the mean, it's got to be negative, right? So that's false. So 3 and 5 are false. We want the true statements, which is 1, 2, and 4. Okay? Now the next statement, remember there was no true answer. I have to change the question. So the question here, we have to talk about number 8, but I'm going to talk about number 9 first. Number 9, the people's names have to be reversed. So if we put Danny and Danny on the top, and then Alan and Alan on the bottom, then the answer would actually be C. Okay, because they mixed the names up when whoever made the test. Okay, for the answers to work with what the logic states, it should have been Danny, Danny, Alan, Alan. So just change them to Danny, Danny, Alan, Alan, and then the answer is C. So whenever we're comparing, now this is a question about basketball team, you got a guy that scores this many points versus a guy that scores this many points. Which one do you want to put on the court first? So that's basically what this is talking about. Don't think, your coaches don't think about this. Now, if Alan scores 14 on his next game and Danny's scoring 16, who's a better asset to their team? Well, we have to take a look at what we had before. Whenever you're comparing who's better, you're comparing standard deviations. You want the lower standard deviation. If we compare z-scores, we compare to the higher. The higher z-score does best, the lower z-score does worst. So, are we asking about who's the better player or who's more consistent? Well, let's see what it's saying. Who's a better asset to their team? So I want the better player. That doesn't mean the more consistent player. It wants the better player. So, if it wants the better player, it's the guy with the highest z-score. Okay? That's what matters. If it said which player is more consistent, it would be the guy with the low standard deviation. Okay? If they wanted consistency. But they didn't talk about consistency. They just wanted to know who's better. When you're talking about who's better or worse, it's always z-scores. Because you want to know where they lie between -5 and +5 on that line. Okay? Because that's what you're actually comparing. All right, the next one. Mrs. Schwartz gave a test to her Math 30 Applied class, and they did very well. Because she's such a mean teacher, she's going to reduce all their marks by 5%. That's terrible. As a result, if she's reducing everybody's scores, will that change the mean? Yeah, it'll change the mean. If she changes everybody's scores and reduces them by 5, your mean will be 5% less. Okay? But does that change how spread out the numbers are if she does it to everybody's score? No, it doesn't change how spread out the numbers are. Okay? So the only thing that's going to change is which one? The mean. Good. The standard deviation does not change. So it's D. All right, let's take a look at the next one. We only have a couple left. And then we'll look at that second practice test and see which questions you'd like me to go through. Okay, number 10. We have model lasts for a mean of 22 days. Let's start labeling. We got mean with a standard deviation of 1.4. Out of this many students, so now we're talking students, whenever we want to find a total amount of something, whether it be bolts in a container or whether it's students in a class, you're always going to be using the probability number and then multiplying it by the people. So we need to be able to get to the probability number. That's what we need to score first. Okay? So we want the number of students who have mono for more than 25 days. Well, if I look at my diagram, if 22 is my mean, 25 is over here. And they want to know how much is lasting for this. So I need to find that probability amount. And then I need to find it and multiply it by the people. So we need a z-score for this x value. So Z is equal to 25 minus 22 divided by 1.4. And we should get a positive Z score because you know 25 is bigger than 22. It's to the right of the mean, which means it has to be positive. So what Z number between negative 5 and positive 5 do we get? 2.14, you are correct. So we get 2.14. That's not our probability number. Remember, probability is between 0 and 1. If I want probability, second bar is number 2. So, second bar's number 2 is normal CDF. Now, in order to use normal CDF, you need a Z score and another Z score. You need a Z score on the left and a Z score on the right. So you need your lower and upper boundaries. This one says more than. So which boundary am I going to use? Positive 5. So positive 5 is going to go second, and 2.14 goes first. Okay? So we got to find our area probability. So how big is our probability decimal? And remember, 4 decimal places. 0, 1, 6, and then it's 1 something, and 1 multiplier, so we round up to a 2. So this number now is the number we're going to multiply by our people to find out how many actual people it affected. So how many people will have mono for more than that? Well, when you multiply it by the people, you're going to get 20.86. So you're going to round that up to how many people? 21 people. Now, if there was a choice of 20 or 21, there is no other choice of 20. You never round people up. You should actually say only 20 people. You can't have 0.86 of a person. However, in our multiple choice question here, it didn't give us a choice of 20. So we had to choose 21. Now, if it gave us the choice of 20 or 21, 20 would be the correct answer. Okay? Even though the 0.86 would round it up, we don't round up for people. Because I multiplied the people number by the probability number. Okay? I multiplied those and got that. Okay? All right. Numeric 5. We only have 3 questions left here, guys. Numeric 5. And again, what's my first thing? I'm going to go through the question when I read it, and I'm going to label. So, the length of the time a calculator will work between needing new batteries is a mean of 18 months. Standard deviation of 3 months. The probability that calculators will need new batteries if they last less than 16 months to the nearest 100. So we want probability to the nearest 100. In order to find probability, I need to have a Z score. So 16 is my X number. So Z of 16 is equal to 16 minus 18 divided by 3. That's going to give me negative 2/3, which is negative 0.6 repeating. Remember, if we have a repeating digit, you use 3 of the digits. Okay, so you're not going to round that to negative 0.7. You're going to use negative 0.666. Use 3 of them. So now we want or less. Here's our keyword less, because that's going to tell us which outer boundary to use. So which one am I using?
Negative 5.
Negative 5. So normal CDF, second bar is number 2, negative 5, comma, negative 0. I put 3 sixes because it's a repeating decimal. Okay? And that's going to tell us our area. We want the area amount. So what's our probability, guys? What you got? Zero 0.25, 27, etc., etc., etc. So, to the nearest 100, 0.25. 0.25 to the nearest 100. Percent? No, it just asks for probability. If it asks for percentage, then you would. Okay? So whenever it asks for percent probability, always make sure that you leave it as a decimal. Okay? All right, 2 last questions. Numeric 6 and multiple choice 11. So multiple choice 11 here, we got the average annual salary is this much for a kid that doesn't complete high school math, with a standard deviation of $800. Ben didn't complete his math, so for him to be in the top 10% of the earnings, well, if he wants to be in the top 10%, what does that mean? Well, that means he wants to be way up here. So, we need to find out the probability for the top 10%. If you're in the top 10%, how much is shaded from here to here? 90, good, 0.9. So 0.9 is here, 0.1 is here. Because 0.1 would be, if you times it by 100, that's your top 10%. 0.9 would be the other 90%. Okay, so you want to be in this top 10%. So you need a z-score for that guy. Well, they gave you the probability number. So we have to inverse norm this one to find the z-score. So second bar is number 3, inverse norm. Now remember, we start the race at the left, so we have to use the probability from the left to the line, which is 0.9. So 0.9, comma 0, comma 1. And that's going to give us our z-score. So our z-score is how big? .28, good. So we know we've got a positive z-score, absolutely, 1.28. Now what we got to do is we got to find the x value. We don't know. So x equals mean plus z times standard. So our mean is 18,500 plus the z-score, 1.28 times standard deviation of 800. So we have to do our multiplying first. So when you do the multiplying, how much do you get? You get 1,024. So you add 1,024 to the 18,500. How much are you going to get? 19,525. Now, you could also work backwards. You could have found the z-score for each of those. If you found the z-score for each of these, you would have found z equals negative 1.28. Z equals negative 0.48. Z equals 1.28. And this guy would be Z equals 2.31. So you could have found z-scores for those guys, okay, and worked backwards and seen which one matched the z-score you found, okay? So there's a couple different ways you could solve that question. All right, numeric 6. The time it takes to finish a marathon is normally a mean of 4.2 hours. There's our mean. Standard deviation of 0.45 hours. Now we're looking for percentage of people that completes between 3.5 and 4 hours. So those are our X numbers. We need to find z-scores for those because we want the area shaded between those numbers. So, just going to erase this. So we want the area in here. So, z-score of 3.5 minus 4.2, all divided by 0.45. That's going to give us negative 1.56. The second z-score at 4 minus 4.2 all over 0.45. That's going to be equal to negative 0.4 repeating. So, we want the information between those two spots on the diagram. So remember, that's like saying you want something that's shaded in between here. It's going to be a small percentage. Okay, we only want a certain section there. So now we have our Z numbers. We're going to go into normal CDF. So second bar is number 2. normal CDF, and we're going to put in negative 1.56, comma, negative 0.444. It's a repeating decimal, so you need to put in 3 of those 4s. You're going to get a decimal of 0.2691. That's our probability. You want percentage. What are you going to do with that number? Times by 100, 26.91. To the nearest tenth, 26.9%. Okay? This concludes the video
to the office, please. Karen, you routed to the office. Thank you.
for practice test number 1 stats.